Hello everybody and welcome back. So we are working in this is what we're going to make, and now we're going to make the vector field in Houdini. And if you haven't followed along in the previous tutorials, you don't really need to do that. If you just need to understand how to make a vector field, you don't need to see the other ones. You can just check this one out. But yeah, if you made the last stuff, you have set up the ghost, and I'm just going to show you. It's going to be a Houdini tutorial now, but we are here and we're going to continue working on it. And the first thing we need to do is to have this mesh as a guidance. So I have it here. So this mesh here, we can remove this one first. So I need to have this mesh in Houdini as a reference. So I'm going to do game object and export to FBX. So I'm going to name it as Houdini reference. And I'm going to make sure I save it in my folder so I find it. So I have this folder, and then object's position, I really need it to be world absolute. I really need to be world absolute, maybe not, but the thing is, I have this in the center of the world, and I'm having this VFX in the world also, and I'm not going to address the world versus object space in this tutorial. I have a lot of other tutorials you can go into if you want to check that out. But anyhow, we have the here we have the reference mesh now. So in Houdini, we made the ghost last tutorial. So now we're gonna import the mesh that we're going to work with. So here is the Houdini ref. And here is the mesh. Perfect. So this is what we're going to work with. And the first thing to compensate for the scale difference in Houdini and Unity, because you can see this one is like 500 meters wide. It says here like 1000. You can read the numbers here. And it's too big, of course. So we need to do it in the correct size. So now we have it in the correct size, and I accidentally moved it a bit. So when I have it like this, now I also want the ground. So maybe I should show you what I'm planning to do. So what I'm doing here is we have the file, and then we're gonna combine it with the ground because we need to have some kind of surface. So we're going to make it a VDB file to have a more smooth mesh to work with. And then we're going to make here I'm going to make this grid, and we're going to make a bunch of lines with these grids. So you see the points here have a lot of lines between them. And the reason we do this, because here later on, we're going to use this find shortest path. So here we have some kind of lines that guide us. And these lines is our guidance. So they know where to follow. So when we have made this one, then we're going to make this volume. So we're going to make this volume here. And then we're going to, in this volume, we're going to use these lines because these lines are resampled with a velocity with it. So in this volume, we're going to do some nodes. So we can make a vector field. And this vector field will stick to the ground, and then it will follow into the cave. And then we're going to use this volume exporter to that Unity have provided for us. So if you don't have this node, you need to look in the description to find out how to install it. So this is what we're going to do. And but we are here. So the first thing we're going to do, hold it. I'm just going to make my notes better. Okay. So we need to have this surface to, to guide us. So the first thing, we need a box as well. That's going to be our ground. And we're going to merge it. So this ground going to be like 20, 20. And also we need to make sure that this ground is not above the ground. So we need to lower it. So it's just aligning to the ground here. And now we have it here. Perfect. So it looks good. And I'm gonna move it a little bit actually, because I want it to be a little bit covering everything around here. So this looks good. Yeah. And then we're gonna do this VDB. So we're gonna do VDB from polygons. So now we make some kind of solid surface. And then I'm gonna do VDB convert. So we're gonna convert it back to polygons. The reason we do this step is because we want to work with solid mesh. So inside here, you see here we have a lot of mesh going on. But now when we do VDB and convert it back, we get a really nice solid mesh. So this is perfect. And also I'm going to do this peak. And what peak is, we actually just growing the mesh in a way. So I'm going to do the peak just a little bit. And the reason is because I want later, I don't want everything to be close to the surface, because when we grow this, I'm going to use it to kind of push back the force field. So now it's a little bit bigger and it's good. Yeah, so this looks good. And the next step for us is to make a box. So now we're going to do, let's see here. I'm thinking about what's the most logic to do for you, I guess. If I make the box first, maybe. Yeah, okay. So down the line, down here, we're going to have this volume. So this needs to cover where the vector field going to be. So this box represents the vector field. And again, I'm going to do it 15 units. And then I'm also going to do -4 here to move it forward a bit, because I want it to cover the most important parts. And I think I'm going to do, yeah, it's going to be good. I'm going to leave it like this. So whenever we come down here, we need the lines to be inside here. So what we also need to do is to make a box here. If I make a box up here, and let's do this to 22, it's kind of a big one here. We're just going to leave it like this. And we're going to make a lot of points in this one. Points from volume. And this is way too much points at the moment. So I'm going to do point separation to 1. So these points, I'm going to make sure that we don't do too many points. We don't need points down here. So I'm going to make clip. So let's plug this one in here. And now you see we're removing points, and we're going to remove it in the up direction. And we don't need the points below. Whoops. Here, yeah, these are the points we're going to work with. So what we're going to make with this is that the kind of guidance things. And I'm also going to do a group we need to remove some more points because we have points inside. We have points inside this mesh, right? So if we only have points here. So if we use if we use this mesh in a group node like this, so first off we do points, and the group name going to be delete or del, and then we do, you see they are yellow now. So if we take the base group, remove, they are black. Then we can do this keeping bounding regions, and we do the bounding object here. So now you see we have yellow points inside the blue mesh. So if we just do a blast here and we remove the del group, now we don't have any points inside. It's a little bit hard to see maybe, but now we don't have any points inside the mesh. So this is really good because now we're going to do a little bit script here. So what we're going to do, we're going to connect points, lines between these points. So it's so we have this run over points here. And the first thing we're going to have a dist. This is going to be a dist. So this is how far are we going to look to make a line. So each point going to look at the neighbor points, and if the neighbor points is within this distance, then we're going to make a line between them. So what we're going to do here, we're going to do int points like this. So now we have made an array, and then we're going to do near points, and then we're going to do, here is 0 is the first input, so we're going to do 0, and then we're going to do @p, so we're going to search for points in the input 0, and we're going to search it from the position @p, and that's the points position. And then how far are we going to look? Well, we're going to look this far. So now we have all the points inside this distance. And what we're going to do with these points is that for int I is equal to usually, 0. And if I is less than the length of the points, then we're going to do I++. This is a regular loop. But what's important here is because we are searching for near points, and because it will find its own point, it doesn't exclude its own point. So here, the first point it finds, it will be the closest. So when this point here starts to look for points, it will find its own point first. So here we're going to change to skip the first point, which is index 0. So now we start on the second one. And here we're going to make a line. So we're going to make a prim. We're going to have add prim polyline like this. So now we created a line, but the line is empty, so we need to add a vertex to it. And it's going to be in the 0 input, and we're going to add the vertex on the prim we just made, and it's going to be the @ptnum. So that @ptnum is what point we're going to use, and the point index for the current point is the @ptnum. And then we're going to add a vertex, and we're going to, on the input 0 and on the prim we just created, we're going to here add the point, the closest point that we found in this function. So now if we add up here, we need, it should work. Let's see. Okay, it works. So it's just that now we see the points find the neighbor. That's 1 unit away, and it won't do any diagonal here. So if we do that, now we did longer, now it finds this. So with these points, we're gonna make the guiding lines. So here, we're gonna make a fuse. We need to fuse because they are all not connected. And we need it to be fused because when we do the find shortest path, we need to have them fused. So, if we have this one here, we want all the points here. And okay, I'm gonna first just do this so you understand. Find shortest path like this. So if we do find shortest path like this, now it wants the starting points. We're going to do the starting points here just to show an example. And then we want the end points. The end points we want inside the cave, and we're going to address that a little bit later. But for now, I'm just going to make it here somewhere. And now you see all the points is finding the shortest path. And we're going to use the tangents of these lines to make it as a guidance later on. But we're going to make this a little bit better. So we're going to make start position better. So now we're going to make a group here. And this group is going to be the starting points. So this is going to be the start. And we're going to have it as points. And we're going to have a box here. So this box here is going to represent all the points. So we're going to make it bigger like this. And something like this. And it's a lot of points in here. So if we look here, we have a lot of points. So, okay, we have points and we're not going to have the base group, but we're going to have keeping bounding regions and we're going to have the bounding object. So now we select all the points, but there are a little bit too many points here. So what I'm going to do, I'm going to make this group range and we're going to do the start group. And I'm just going to make sure that we're going to have points here. So here you see now we can start to take less points because it's going to be a little bit heavy computing. So I'm just going to do less points. And now we need the goal point that we're going to make. And so we're going to make a wrangler here. This wrangler, we're going to use that to make the point. That's going to be our goal. So if we look at this mesh here, we want the goal to be inside at the bottom here. So if we make an add node and we do here number of points, we do 1. So if we press enter in here, now we can move this point around. And it's a little bit hard to see where we have it, but we can just do this snap to points. And now when we move it, it will snap to points. So now it snaps to the end tunnel part here. So when we have this goal point in here, we can use it in a node. So this node, we're going to have it as a detail because now what we're going to do, we're going to use this point here that we created and find the closest point in this grid. And we're going to make that into this to the goal group. So the way to do this, we're going to have a vector. And it's important you do this detail only once. So we're going to have center, and the center is going to be the point from the second input. And we're going to find the position, and the point number is 0. And we're going to do near point is near point. So we're not going to do near points. We're just going to do near point in this one. And here we're going to look in the first input, and we're going to look with the position center. And now we found one point. And what we do now is set point group. And we're going to do it in the first input, and it's going to be the end. And we're going to do near point that we found. And we're going to make 1 is like it's inside the group, and 0, it's not in the group. So we're going to do that, and then we're going to make set. So now we have 1 point. So if we check this one out now, here we have group end. And if I click here, you see we have 1 group here. So now we can just change this to be the start, and this is going to be the end. Here you can see, if we reference the mesh, you can see it's kind of going between the rocks. It's avoiding the rocks, and it's going inside. So you see they are not going, yeah, they're actually going through here. But what we can do is to crank up the resolution here. So now we have more points, and it's working. Yeah, it's actually still going through. Yeah, but that's fine. We're going to make another mesh that's going to help us later to make it even better. So why is this? So when we delete the points here, yeah, we have deleted everything inside. Okay, it seems like it's going through anyway. So yeah, it is some intersections. I mean, it depends on how detailed you want it to be. It's yeah, it intersects a little bit, but I'm gonna address it later. So we're gonna leave that for now. So just to wrap up the video, it's getting a little bit long. Now, actually, I'm gonna pause it here and continue in the next tutorial. So thank you if you managed to look this far. It might be a little bit overwhelming, but the final result's going to be really good. So thank you so much for watching, and see you in the next one.